This video is about combinations of functions. And so a combination of function is just the addition, subtraction, multiplication, or division of two functions or more than two functions. So that's what it means. So one thing that we're going to learn in this video is first the notation on your worksheet. And there's a gray box at the top that talks about sort of the notation of combination. So we can have two functions in which we add together. And so that marker is not any good. So let me try again. If we have f plus g of x, and it's written like this, what this means is function f of x plus g of x. And so as you go through that little box, it shows you that I have at the top of your worksheet, it shows you the notations right here. Minus g of x. F times g of x is f of x times g of x, and then f over g of x is the division of f of x over g of x. And of course, this is for the cases where g of x does not equal to 0, because we're never allowed to divide by 0. So that's just what those mean. And so on your worksheet, I have a few examples for us to do. So let's start with number one. The function in example number one says f of x is x plus 5, and g of x is 3x minus 1. Okay, we have two functions, and if you look at these, let's just look at these for a second. These are two lines. Those are both linear functions. This has got a slope of 1, a y-intercept of 5, slope of 3, y-intercept of -1. But these are linear functions, just to take note of those. Okay, so if we're going to, part A says add f plus g of x. It says do this for these two functions. So we're going to do f plus g of x. This is for example 1. This is simply going to be f plus g of x is simply x plus 5 plus 3x minus 1. Now, when you come, I put parentheses around this to denote that this is f of x and to denote that this is g of x. But when you're adding, whenever you come across a parentheses, if you don't see anything out in front, you know that's a positive 1. And when there's a positive 1, you are allowed to just remove these, because if you were to distribute the 1 across, it would look just exactly the same. It doesn't have an effect. So now we will just simply simplify this by collecting like terms. 1 plus 3x is 4x. 5 plus -1 is 4. And so this is what f plus g of x is equal to. Now if they ask us to find f minus g of x, let's do that one. F minus g of x, all right. That is just f of x, x plus 5, minus g of x, 3x minus 1. Now I want you to watch carefully here. On this parentheses, there's a positive 1 right there. That means I don't really need them. On this set of parentheses, I do not find a positive 1 right there. I find a negative sign, which means -1. To free up these terms, you must distribute it to both terms. So this will be -1 times 3x will be -3x, and a -1 times a -1 will be a positive 1. And at this point, I'll combine like terms. So that's really important. 1 minus 3 is -2x. 5 plus 1 is 6. And this is what f minus g of x equals to. So that's simple enough. F times g of x would simply be the multiplication of these two. So it's going to be x plus 5 times 3x minus 1. So hopefully this is what you've done a whole lot of. X times 3x is 3x squared. X times -1 is -x. 5 times 3x is 15x. 5 times -1 is -5. If we collect like terms, we're going to get 3x squared plus 14x minus 5, just like that. F over g of x looks like this. F over g of x is simply x plus 5 over 3x minus 1, and we're going to leave it just like that. You don't have to do a big division there. And so g over f of x, that's the last thing we had to find. G over f of x will simply be 3x minus 1 over x plus 5, just like that. Okay, that was part A for number 1. Now look at part B. Part B says f of g of -5. So I'm going to do that in a different color. I'll do it in blue. If we have to find, this is part B, f plus g of -5. You have two choices here. If you have already discovered what f plus g, the function is right here, this is what f plus g, the function is, well, you can just stick then f plus g of -5 would be where I replace x in this with -5 in this function. So that's 4 times -5 plus 4, or -20 plus 4, or -16. That is one thing you can do. But if they give you a number, another option you have is to evaluate f of -5 plus g of -5, and that will give you the same thing. Well, let's go about it that way. What is f of -5? Well, it's -5 plus 5, or 0. What is g of -5? It is 3 times -5, which is -15, minus 1, which is -16. So we could say, what is f of -5? We could just say, okay, that's 0. Plus, what is g of -5? That's -16. And you see that you get the exact same answer. So when they give you a value, not just an x, you can plug in the value and evaluate it that way if you choose to do it that way. Let's see. So then for part B, it says find f times g of -5. Since I have f times g of -5, let's do it this way. F times g of -5 is equal to f of -5 times g of -5. Since I know that f of -5 is 0, and I know g of -5 is -16, when I multiply these two values together, I get a 0 right there. I chose to do it that way. If you decided to plug it in here, you should get 0 as well. Oh, this should not have a squared on it, should it? So that makes me think you won't get 0 as well. Oh yes, maybe you will. Oh no, we should do that. I need to verify this because it's bugging me. So that's what I got to do in math. When something bothers me, I just got to check it out. This is 3 times -5 squared plus 14 times -5 minus 5. -5 squared is 25. 3 times 25 is a 75. 14 times -5 is 20, 5, 6, 7. Okay, -70 minus 5. Okay, I will still get 0 that way, so I didn't make a math mistake. Okay, now I can go on. That was just bugging me. Let's see. The last thing we had to do was find f over g of -5. F over g is right here of -5. So f over g of -5 is going to be -5 plus 5, a 0, over -15 minus 1, -16. So we get 0 divided by -16 is 0. What is g over f of -5? We got -16 over 0. And this right here, that's a problem because we're not allowed to divide by 0. See, you're not allowed to divide by 0. What this means is -5, x is not allowed to equal -5. So what we've come across is our first sort of domain issue. Yes, these are lines, and so their domain is negative infinity to positive infinity, but when you start combining them in functions, you have to watch out that you're not dividing by 0, and I'm going to show you how to do that a little later. Okay, let's go ahead and do number 2. Number 2 is just the same sort of thing, but with different functions, so we'll do this pretty quickly because I want to save the last little part for the domain talk. So now that you know what these things mean, I'm going to erase this top part. And example 2 goes like this. They gave us 2 new functions. One is called h and one is called m. And so h of x is equal to, let me get my little sheet. H of x is equal to 4x minus 4. Okay. G of x, no not G, m of x is equal to x squared minus 9. Okay, we're going to do the same sort of thing. Let's find h plus m. Part A, h plus m. H plus m of x is going to be 4x minus 4 plus x squared minus 9. We will collect like terms. We'll get x squared plus 4x minus 13. That's what h plus m of x is equal to. How about h times m? H times m of x. What does that equal to? Let's see, 4x minus 4 times x squared minus 9. Let's see, 4x times x squared is 4x to the third. 4x times negative 9 is negative 36x. Negative 4x times x squared is minus 4x squared. And 4 times negative 9 is a positive 36. So h times m of x gives us this new cubic function. 4x cubed minus 4x squared minus 36 plus 36. So not all that hard, but it's important that you understand what these notation means. The last one is h over m of x is equal to 4x minus 4 over x squared minus 9. That's all I'm going to do with that. M over h is x squared minus 9. That looks like a 4. X squared minus 9 over 4x minus 4, just like that. So part B, what does it ask us to do? Evaluate these for values. Again, we have the choice. We could figure out what h of x is and what m of x is at those values and plug them in like that. Or if we've already calculated these, we can plug them in here. Let me just do it with the values way. What is... Okay, there goes my dog making a lot of noise. What is m of 1? Let's figure what m of 1 is. And then m of 1 is equal to 1 squared minus 9. 1 minus 9 is negative 8. That's what m of 1 is. Okay. What is h of 1? That's going to be 4 times 1 minus 4 or 0. Okay. So now let's go down here, and what is m plus h of 1? M plus h of 1 is equal to m of 1 plus h of 1. Well, m of 1 is negative 8. H of 1 is 0, so it is equal to negative 8. There's the first one on part B of number 2. What about h times m of 1? Okay, h times m of 1. H times m of 1 is h of 1 times m of 1, which is a 0, times negative 8, which is a 0. Okay? What about h over m of 1? H over m of 1 is, h of 1 is 0, m of 1 is negative 8, and this gives me a 0. All right. What about m over h of 3? I don't want to change that to a 1. M over h of 1. M over h of 1. That gives me m of 1 is negative 8. H of 1 is 0. And we see, oh, it's in our second domain issue here. All right, so what I want you guys to see is that there can be domain issues. So when we talk about it, you'll realize we have to be a little bit careful. Finally, let's look at this graph right here. Okay, that graph right there, and I really am not sure when I created this, when I drew it on my board, if I got the red and the blue colors in the right order as is in your sheet. So if I got the G and the F in the wrong color, please forgive me. What I want us to do here, when we look at this, for number 3, we're starting to talk about domain. So before I read the full domain, let's just look at this graph. Here's a graph of a function g. It is a function. It passes the vertical line test. F is a function. It passes the vertical line test, as you can see visually. What I would like you to do is look at the chart and on your handout or on my whiteboard and say, what is the domain of g? So you know when you're given a graph of a function, you can just ask yourself for domain, which means x, how far to the left and how far to the right does my function go? So when they say, what is the domain of g? My graph starts right here, and this is the x value 1. It goes from 1 all the way to this x value, which is 9. And 1 and 9 are included, so I wrote it with brackets. What is the domain of the red function f? Okay? The domain of the red function f is from, it doesn't start till 2, and it goes all the way to here, which is 11. I think that's 11. Did I draw it right? Yeah, 11 is what it should go to. 11. Okay, so that's the domain of G, and that's the domain of F. Now, when we start to combine these, add them, subtract them, multiply them. So, if I were to say, hey, what's the domain of G plus F? F plus G. G minus F. F minus G. G times F. F times G. These combinations, not the division one, these combinations. How you do that is you can't let anything into F or G that can't go into both of them. What I mean is when you look at this, if you were to say, hey, what part of these domains is in both functions? You would say, well, look over here. You see how there's part of the blue that's not including the red? But about right here, they're the same. Right here, they're the same. Between, oh, that is dry. That's got to go in the trash right there. Trash right there. Okay, now look. 2. They both have, I thought that was purple. They both have 2 right there. Okay. That's where they start being the same. And then where do they start? At 9, they're the same, right? At 9, they're the same. But then there's some red that's left over. We can only include in the domain of the combination of these, that's both of those. So what is the domain of any one of these? The domain of any one of these combinations is going to be the same. It is going to be what's contained in both from 2 to 9. The reason I chose purple is because red and blue makes purple. So that's why I did that domain purple. Now, we have to be careful. When we introduce a division, we introduce the possibility of dividing by 0, just like when we had rational, fractional functions, we had to worry about that. So, if they say, what is the domain of G over F? And what is the domain of F over G? We have to be careful. Already, we're restricted to this only where they're both in there. But if the denominator function ever has a 0 in it, we can't let that x value in. So let's just see here. Where, who's in the denominator for this one? F is. So let me just write this like this. We'll do this. G over F. G over F. Over F. Or F over G. Okay, so here. When we're doing G divided by F, F is in the denominator. That's what we cannot let, we can't divide by 0. So we look at this graph and we say, does the red function, the F function, ever become 0? And it does. The x-axis is where the y value is 0, and it becomes 0 right here. And you say, well, what x value is that? That x value is 3. So this is be the domain of a combination. Already we're restricted, only what those both included, but we can't let 3 in either. So the domain of these two will be, of F, G over F would be from 2 all the way as close as we can get to 3 without including him, and then just to the right of 3 to 9. This is the domain of the combination G divided by F. What about the other way, F divided by G? Is it the same? We have to look and see. This time we're concerned with, does the G function ever hit 0? Well, the y values are 4 to 1 to 5 to 1, but it doesn't ever come down and touch 0, so we don't have to restrict anything extra. So the domain of this guy is still all of the values that included both of the functions. So that's how combination functions domain works. So let's go back and look. We came across a couple of problems. Number 4, I'm on number 4 on your sheet. Given the h of x is 4x minus 4 and m of x is x squared minus 9, the same as they were before, right? H of x is 4x minus 4 and m of x is x squared minus 9. Then it says find the domain of h over m of x. Okay, so first we have to say, what is it? We can only include what's in the domain of both of these, but already, what's the domain of h? This is a line, and it can go from negative infinity to positive infinity because there's no division by 0 or square roots or anything. This is a parabola, but a parabola's domain is negative infinity to positive infinity as well. So the domain of M is also negative infinity to positive infinity. So if we have a combination that simply involves addition, let's do part C first because that's the easy one. This is A, this is B, and part C says H plus M of X. This is just a combination like one of these. All you have to do there is keep what's in both of them already. What's in both of these guys already is all the real numbers. So the domain of this one, this domain is negative infinity to positive infinity. Now where we have to be careful is where we've introduced a division. So when we introduce a division, H over M of X, that's 4x minus 4 over x squared minus 9. We cannot let anything in here that will cause division by 0. So, x squared minus 9, I am going to factor this. This is difference of squares. And that helps me see what values I could put in for x that would cause me trouble. And the troublemakers are 3 and negative 3. So the domain of this guy is going to be all the real numbers except for 3 and negative 3. And you write it like this. Negative infinity to negative 3. Don't include negative 3. From negative 3 to 3, don't include 3. From 3 to infinity. That is the domain of this combination. What about if it's M over H? Well, that is x squared minus 9 over 4x minus 4. Now you have to ask yourself, when would this ever equal 0? And you could set this equal to 0 and solve, and you find out that if you let x be 1, you are looking at a 0 in the denominator, and that can't happen. So the domain of this guy is going to be from negative infinity to 1, union with 1 to infinity. And the reason I'm using parentheses here is because it's not allowed to equal 1, so you can't throw a bracket on there. So this is combinations of functions.